Hi friends, in the last video we learned up to this the major factors of the resistance that are frequently asked in the Madhyamik exam and also the board exam of the CBSE and ICSE, where we learned that the length of the conductor that is directly proportional and the resistance offered by the conductor is inversely proportional with the area of cross section, and the temperature to which the resistance offered by a conductor is directly proportional. But these are the different factors. In this video also we learn the another some factor like the magnetic field, the pressure, the light. These are also the factors. They affect the resistance offered by the conductor very little. Let's see how does the resistance offered by a conductor vary with the length mathematically, that are frequently asked in the board exam. Let's see, they are directly proportional. If the, let us consider this is the length of the wire, let this is be L1, the copper wire, the thickness of the wire are same, another one wire, copper wire of same thickness, the length of the copper wire be relation for equal thickness. Another one, let us just imagine the filament of the electric wire. It is very thin and long because of to offer the more resistance. Thin wire offer more resistance, whereas thick wire offer less resistance. The thickness of the wire is considered to be as the area of cross section, that is a circular end. Any one end, if we cut the wire, then we get the circular end of it, that is mathematically area A equal, for radius r, smaller be the radius of the wire, let this is be the axis, so this is the radius smaller, so A equal pi r square. So for a thin wire, let this is be the wire, this is be the wire having the same length, another one wire is here also having the same length, let the length of the two wire be same. Now what happened, this is thin wire, this is the thin wire radius r2 and the thick wire radius r1 of same length, equal length. Then what happened, then we see that if the resistance offered by the first wire be capital R1 and the resistance offered by the second wire be thin wire be R2, then we see that the R1 less than R2, that means thin wire offer more resistance for equal length. Mathematically, how can we represent this? Let us consider R proportional 1 by A. Thin wire means the area of cross section is less, that means the radius is less, so this is the standard relation, this is the standard relation, also this is the standard relation with the area cross section, inversely proportional. Mathematically, for two wires we can write this as R1 by R2, this is equal A2 by A1, inverse relation A2 by A1. Similarly, for the two wires, in case of the length we can write R1 by R2, this is equal L1 by L2. As they are directly proportional, so the relation will be this. Very frequently asked question, the ratio of the length of the wire will be given in your question paper. We have to find out the ratio of the resistance offered by the wire in every year, either R1 by R2 equal L1 by L2 or R1 by R2 equal A2 by A1. Also that can be written as in the relation with the radius R2 square by R1 square, R2 square by R1 square. Okay, so in your question paper that is frequently asked, that are the questions, these are the two wires of length having ratio 1:2, the length of the ratio of the wire, numericals related to the resistance and their factors. The first one resistance, first one numerical, frequently asked in your question paper and the test paper also, that is if the ratio of the length of the two wire be L1 is to L2 1 is to 2, that is if the length is ratio of the length is given 1 is to 2, then what will be the ratio of their resistance? Find the ratio of their resistance. That will be the question. Very simple, very simple. R1 by R2, this is equal L1 by L2. L1 by L2, since L1 by L2 is given, L1 is to L2, that is given 1 is to 2. So the ratio will be 1 is to 2. That means R1 is to R2, this will be 1 is to 2. Very simple question. Answer is very easy. And another one question, if small r1 is to small r2 equal 1 is to 2, the ratio of the radius of the two wires are 1 is to 2, then find the ratio of the resistance offered by the two wire. What will be the answer? Very frequently asked question in your board exam. Very frequently asked with this value 1 is to 2. Okay. Let's see R1 by R2. Just remember the relation R1 by R2 equal A2 by A1. From this relation we can write this is A2 by A1, or you can write also directly, that is R1 by R2. This is equal small r2 square by small r1 square. But according to the given problem, the ratio R1 by R2 small r2, this is given 1 is to 2. So we can write this as the result, that is the given small r1 by small r2. So we can write this R1 capital R1 by R2 ratio of the resistances, that will be R2 square by R1 square, that means 2 by 1 square, 2 by 1, 2 by 1 square, that is equal 4 by 1. Therefore the relation will be R1 is to R2, this is equal 4 is to 1. This result also shows that the thin wire offer the more resistance, thin wire offer more resistance. But mathematically, again, this is very frequently asked question. We can establish the relation between the factors of the resistances like the length, the area of cross section, and the nature of the material. For a good conductor, resistance will be less. For bad conductor, the resistance will be more. For the semiconductor, resistance will be more. That's why very less amount of electric charges or electric current can flow to the semiconductor, because of the very few electric charge carriers are here in case of the semiconductor. That means the resistance will be more. If we supply the heat, if we raises the temperature of the semiconductor, then we see that the electrical jumps from the valence band to the conduction band. As a result, the electrical conductivity increases with increasing temperature. Okay. So let's see here another one important question, another one important question from the resistance, that is, so from these two relation we can write R proportional A and R proportional 1 by A. Mathematically we can write this as, when L and A both of them are varies, then we can write this equal L by A, or R equal rho. A proportional constant should be introduced if we use the equal sign instead of the proportional sign between the standard relation of some physical quantities. So this rho, this is the specific resistance or the resistivity of the material. Very important question for your board exam. For your board exam, this is very important. So rho is the, this is the rho is called the specific resistance. Specific resistance, or simply this is called resistivity. This is called resistivity. By using this relation we can find out the unit of it, and also we can define this. What will be the rho? So rho equal, from this relation we can write this is equal R into A by L. R into A by L. So how can you define this? To define a physical quantity related some other physical quantities that can be described with the help of a standard relation, first we have to make the denominator 1. So first we have to make the denominator 1. If L equal 1 for unit length of the conductor, and then A equal 1 for unit area of cross section, for unit area of cross section, what happened? Then then the resistivity of the material will be the resistance offered by the unit area of cross section of the conductor in unit length. So in another word, we can write this as, for unit cube, the resistance offered by the unit cube will be the resistivity of it. And this resistivity, that is also have particular units. If we use the find out the unit of the resistivity, easily you can find out this. Easily you can find out this. That is R, rho equal R into A by L. That will be ohm meter in CGS. In CGS, that will be CGS unit of resistance is stat ohm. This will be centimeter. This will be stat ohm centimeter. That is not necessary for your board exam. Only this is sufficient. Only this. The SI unit is ohm meter. Okay. In the next video, we again learn another some important term that are frequently asked in the question paper. Okay. So today up to this.